With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given that an alkene C5H10 on ozonolysis gives a mixture of two compounds Y and Z. What is given about Y? That Y gives positive Fehling's test and iodoform test, but compound Z does not give Fehling test but give iodoform test. Name the compound formed when Z reacts with MgHgH2O. Okay, fine. So our first aim is to find out what is XYZ. So you have been given that Y gives positive test with Fehling as well as iodoform. It means that Y must be an aldehyde because aldehyde gives positive test with Fehling solution, and on top of that Y should have a keto-methyl group. What do you mean by keto-methyl group? I will explain. Y should have keto-methyl group. What is keto-methyl group? It is like this: C double bond O. Here there can be any R, but here CH3 must be present. So here you can see that it's a keto-methyl group. That is, methyl group is present adjacent to a keto group. So this indicates that it should have a keto-methyl group and it is an aldehyde. If you talk about Z, Z does not give Fehling's test. It means the ketone do not give Fehling's test, and here it gives iodoform test. It means that it has keto-methyl group, right? It also has keto-methyl group. Fine. Now what is important? Your aim is to get what should be that alkene. So if you talk about this alkene, if we draw the single chain alkene like this, if you have 5 carbon is given, so here if you draw like this, here CH3, here CH3, and you can draw anywhere. Even if you draw the double bond here, then here there will be 1H, there will be 1H, and here there will be CH2. Now you can see very well that if you draw the double bond, or if you make such alkenes, then in this alkene, on ozonolysis, reductive ozonolysis, what you will get? You will always get the formation of aldehydes. All aldehydes will be formed. Only aldehydes will be formed. Because when you will break this bond, you will have double bond attached here from both the sides. So you will always get the formation of an aldehyde if you have a single carbon chain. But according to question, after ozonolysis, one compound should be aldehyde, the other compound should be ketone, both should not be aldehyde. So for that what you need to take the compounds in such a way that it should have a methyl substituent. I will tell you, you can take it like this: CH, double bond, C, then you can have double bond C, and here what you can have it like CH3 here, and now here CH3. Now this compound is also a compound having 5 carbon, but here the carbon skeleton, that is the main carbon chain, is of 4 length only. In this way you can have a ketone as well as an aldehyde on ozonolysis, reductive ozonolysis. So if you do ozonolysis in presence of zinc dust, you will get the formation of H3CCH double bond O, and along with that you will get the formation of C double bond O, CH3. What happens? This bond breaks and double bond O gets attached from both the sides. So this is how you get the formation, right? Now here you can see this is the aldehyde. This is the aldehyde which is present, and this is the ketone which is present. So definitely you can say that this is satisfied. Y is an aldehyde, Z is a ketone. But let's see whether they both have keto-methyl group or not. So if you draw the first structure, that is of the aldehyde, if you draw the structure of the aldehyde, it is like CH3, C double bond OH. This is the first structure. And if you draw the structure of the ketone, it is the acetone only, C double bond OCH3, here also CH3. So you can see that in both these compounds you have keto-methyl group, here also and here also there is keto-methyl group, and it means that both the compounds are going to give the positive iodoform test which was written here also. So what you will say that the aldehyde is Y and the ketone is Z. So we have find out that the ketone is nothing but it is acetone, right? It is acetone. Now what is given? that name what you have been asked. You have been asked that name the compound formed when Z reacts with MgHgH2O. So actually what is MgHgH2O? Actually reduction reaction is performed. This is a very famous reaction when acetone reacts with MgHg water. Phenol, this is very important. Phenol is formed. This is the compound which is formed. I will tell you how the reaction takes place. Actually, 2 moles of acetone basically reacts. 2 moles of acetone reacts in presence of MgHg water to finally give you a formation of 2 moles of acetone reacts to finally give you the formation of CH3, COH, CH3. Then again one more acetone will be attached like this, and finally this is the compound which you have formed, and this is nothing but it is an example of phenol. This is a phenol, right? So diols are formed, and this is only this is how the reaction takes place. So finally name the compound which is formed. So you will say that the compound which is formed is phenol compound, and if you want to write down its IUPAC name, then its IUPAC name will be, so its IUPAC name is 2 2,3 dimethyl 2,3 dimethyl butane 2,3 diol, butane 2,3 diol, right? And this is nothing but it is phenol, right? So 2,3 dimethyl butane 2,3 diol. This is the compound which is formed on reacting with Mg ether. This is the reduction reaction is performed when acetone reacts with MgHg ether. Phenol is formed by reduction process, right? By reduction process, reduction reaction is performed, and this way it reacts in order to give you phenol. I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.